Hey guys, sorry I had to stop the video in order to take the call from the departmental chair at Tech so that I could find out about the semester exam, so I guess that was worth it. Anyway, so I think I was explaining if the other side length is larger than the length given, right, than off of this. So here's the thing. If I try and create a triangle with this, the only thing I can do is swing way over here, creating one triangle. And I mean, you could say, well, you could create another triangle if you swung it past it, right? And so create a triangle with this horizontal length down here, and then create this obtuse triangle. But that no longer uses this angle, so it doesn't count. Okay, so if the side length is greater, then it only creates the one. So if this is longer, if this one is longer than that one, let me zoom in. A bit closer. Okay, then there's only one triangle. So let's clear this up. Okay, so if we have zero triangles if side A is less than the height. We have one triangle if A equals the height, or if A is greater than or equal to B, in this case with this image. Oh, sorry. We have zero triangles if if the side across from A is less than the height, didn't create a triangle. We have one triangle if A is equal to the height, creating the right triangle, or greater than or equal to B, so it's the same length or longer. And then we have two triangles if A is greater than the height but less than B, so if it's some length between these two lengths, right? Okay, so that's basically what we need to know. Alright, so let's do another example. If I ask you, or if I give you, let's see, okay, let's see, yeah, okay. So first off, if I tell you angle A is 36 degrees, side A is 2, and side B is 7. Then what we can say is, or what we're going to do is we're always going to put the angle along the horizontal, and then go off like this. So 90 is right there, 45 is right there, 36 is somewhere in here, right? So we're going to say this is 36 degrees, and we're going to let that be A. I don't know how long this side length is, so I'm just going to call it right there. Now, the other thing is, I've got side A and side B. Side A cannot be off of A. Side A has to be created by the angle of A, so it has to be over here somewhere, right? So we're going to let this side be B, which equals 7. So then the question is, if side A is 2, do I have 0, 1, or 2 triangles? And then if I have 1 or 2 triangles, then I need to solve them. In this case, what we're going to do is we're going to first find the height, because that's one of the first things we've got to do is determine whether or not it fits if it even makes a triangle, right? So I'm going to label this the height, and here's what I know. This is opposite and this is hypotenuse according to this right triangle. So we're going to say sine of 36 equals height over 7, and so height equals 7 times sine of 36. So 7 times sine of 36 equals 4.114. So the height is 4.114. So when I think about a side length of A being just 2, 2 is not even half of this length. So if I have a string hanging off this, it's only a length of 2, inches, and it's supposed to, and even to reach this line, creating that angle, it has to be 4.114, and it's not even going to reach it. So this is no triangle possible. Or you can just say A is less than H, which means 0 triangles. It forms 0 triangles. Okay. Now we're going to do this one. What if I give you if I give you C equals 30 degrees, A equals 18, and C equals 9. Okay? So 30 degrees is my angle, so I'm going to draw the horizontal. 30 degrees, somewhere in here. Okay. This is going to be angle C. And then I can't let side C be this this side length, and I have no idea how long that is. So I'm going to let A be 18 right here. Okay? Which means I need to let side C be this length right here. If it goes here, if it goes here, if it goes there, if it goes out, it could go way out further. And so what we need to do is first find the height. Sorry, I gotta answer this right quick. Hey, I'm making a video right quick. Can I call you back? I'm making a video right quick. Can I call you back?
I'll put the phone down. I ain't making no noise.
Okay. Alright. So, if I want to find the height, then I'm going to set it up and say sine of 30 equals height over 18, so opposite over hypotenuse. So we're going to solve for height. 18 times sine of 30, and I get 9. So the height is 9. Okay, so here's the thing. If side C is 9, that means it's exactly the same length as the height, which means it couldn't swing side to side. If it swung side to side, then it would be above the line, right? It wouldn't create 2. So in fact, it's just the 1. So since C equals the height, we only have one triangle possible. Okay? And then let's do this next one. We've got B equals 82 degrees. So angle B is 82 degrees. Side B is 17 and side C is 15. So I'm going to create an angle that's 82 degrees. So here's my horizontal. 82 degrees is pretty close to 90, so it's actually something like this. Probably even higher than that, but I need to give myself something that's not quite vertical. So that's going to be angle B. I can't let that be side B, so I'm going to let that be side C, which is 15. So I'm going to find, well, I don't even have to find the height, because here's the thing. The height, we know, is less than 15, because the 15 is diagonal. The same side, 15, rotated over, if I rotated this over, that would be 15 as well. We've got a side length that's 17, that's even longer, right? So it's like over here. If B is greater than C, then we have just the one triangle. It goes past. It doesn't land in between the height and that length, and in fact it goes past that length right there. And so I don't even know if you can see all my dotted lines. Right. So this length right here is the height, which is less than 15. This length right here would be the same as 15. So if the 15 swung over, we've got a height or a length of 17, which is greater than that. So we only have the one triangle. Okay. Now let's do another type of problem. What I'm going to do is I'm going to give you a premise where I've got an angle and a side length, and I'm going to ask you to tell me all the values. Well, I would ask you to tell me, but you're not here. To tell me all the values, unless you want to pause it after we start the problem, of the side length that would give us 0, 1, or 2 triangles. Okay? So say I tell you that A equals 10 and angle B equals 42 degrees. And the question was, for what side lengths of B will you have 0 triangles, 1 triangle, or 2 triangles? Okay. It says values, but it looks like ratios in the... Okay. So angle B is the angle we're given, so I'm just going to draw that. I'm going to go 42 degrees somewhere in here. And I'm going to label that angle B. And I'm going to let this side be 10, and that's side A. Okay? So the first thing we need to do is find our height. So, sine of 42 equals height over 10. So let's solve for the height. 10 times sine of 42, and that gives me 6.691. So if the height is 6.691, then we can, like after this, we can know every value that we need in order to create 0, 1, or 2 triangles. So 0 triangles, and if you want to pause and try and work this yourself, feel free, and then check yourself. There will be 0 triangles if side B is less than 6.691. So if B is less than 6.691, then there aren't going to be any triangles. There's going to be one triangle, and only one triangle, if B equals the height, so if B equals 6.691, or, remember the other option is, if B is exactly the same length as A, 10, or if it's greater than 10. That would be the only way that we'd have just one, is if it equals this same length as this one right here, or if it's longer, then it can create a triangle out there. So if B is greater than or equal to 10. And as far as 2 triangles, it's the only lengths that we haven't addressed. Any length that lands between 6.691 and 10 would be something that could go here, or it could swing over and be here, and that could create two different triangles. So here could swing over here. So any value between these two. So we would say for B, greater than 6.691, but less than 10, and that would be what would give me. Oh, that looks terrible. 6.691 less than B, less than 10. Okay. Let's see. What do I have us doing next? Okay. Let's solve one more where we have 2 triangles, and then we'll call it good. Okay. So, just to get some practice on this. If angle B equals, let's say, 43 degrees, angle, or side, let's go with A, equals 17, and then side B equals, well, I just need to be greater than the height, so let's go with 13. Okay. So if you didn't know that there was going to be 2 triangles, then you would have to set it up and see, set it up and solve. So I'm going to draw the horizontal, draw the 43-degree angle, and then we're going to label that angle B, and then we're going to let this be side A, which is 17, and then we're going to draw our height. So we need to figure that out. So sine of 43 equals height over 17. So if I solve, then I get 17 sine of 43 equals 11.594. So the height is 11.594. Okay, so the height is almost 12. B, our side length that we have across from angle B, is 13, which is greater than this by 1 and a little bit, right? So it's like somewhere in here, okay? So this could be the length B, or this could be the length B. Ugh, that's a little bit higher. Whatever. So this could be the length B as well. B equals 13. Okay, so in this case, this is going to be angle A1, this is going to be angle A2, and then we've got 2 different C angles up here, right? So what we're going to have to do is draw 2 different triangles. I'm going to zoom in just so we can make sure you can see that. Okay. So we've got angle B, 43 degrees. The height is 11.9 or 594. So the 13 is a little bit longer than that, so it could land here or it could land here, right? So I've got a length of 13 hanging off this length of 17 at this angle. And so if I bring it down, it could hit this horizontal created by this angle, right? And it could hit it here or it could hit it here. And that would still create, it would still satisfy the conditions of this angle being 43 degrees, this side length being 17, and this side length being 13. Okay, so let's draw two different ones. I'll refocus in a second. And if you don't need to redraw them, that's fine. I just suggest it helps you keep track of what you're doing. So that's kind of up to you. So my angle's a little bit exaggerated, but that's okay. So there's angle B at 43 degrees. Here's A1. Here is C1. And here, I don't know why I did the 1 so large, but I did. Okay. A is 17. B is 13, and this is side C1. Okay. Then we've got the other angle. Or the other triangle, created by the same angles. So this angle again, but this time it goes over here. So we've got angle B, 43 degrees, A equals 17, B equals 13, but now this is C2, this is side C2, and this is angle A2. Okay? Now the reason why I have this labeled A1 and A2 just because of order, but at the same time, like, if you remember from what we did, you're always going to be able to solve for A2, not A1 first, but it's kind of whatever. Okay, so in order to do the work for this one, I'm going to put out to the side where I'm going to put all my answers. So I need angle A1, angle C1, and side C1, right? Over here I need angle A2, angle C2, and oops, side C2. Okay. Keeping in mind, knowing that I'm going to solve for A2 first, because that's how the law of science always does it, we're going to set it up and start working this one. So, angle and a side pair. I'm trying to solve for an angle, so I'm going to put that first. Sine of angle A over side A equals sine of 43 over side B. I'm going to solve for angle A by multiplying by 17, so 17 sine of 43 divided by 13, and then I'm going to take the sine inverse, and that equals A. Okay, angle A. So let's type that in. 17, or sine inverse of 17 sine of 43 divided by 13. Now a lot of you guys tend to, put parentheses around your whole numerator. You don't have to if it's just multiplication division. It's order of operations. So then this is 63.106 degrees. Oh, sorry. You couldn't even see what I was talking about. Sine inverse of 17 sine of 43 and then divided by 13. Okay. So 63.106 degrees. So A2 is 63.102 degree, or 106. Yeah. Okay. So this angle, 63.106. And then if I want to solve for angle C2, then I'm just going to do 180 minus the 2 that I have. So 180 minus, so that's 106.106. So 73.894 degrees. 73.894. Okay. So this is 73.894 degrees. And then we need to solve for side C2. Okay, we're going to have to do law of sines again. I'm trying to solve for a side length, so I'm going to put that first. Over sine of its angle, so sine of 73.894 equals, and then we're going to do an angle and a side pair, that we were given. So side length goes on top, 13 over sine of 43. And then to solve for C, all we gotta do is multiply by the sine of that. So I've got 13 sine of 73.894. And I know I have the whole, like, all the decimal not rounded typed in, or, you know, in the calculator before, but I want to go ahead and use the 3 decimals so that, you know, and please do, once you round that first set of decimals, just use the numbers that you got. Well, no, I guess this one was just exactly that. Never mind. Okay. And then divided by sine of 43. 18.313. So that means side C2 is 18.313. And does that make sense? It does. This being longer than that because this is, if it was exactly the same length, then this would be, well, these two angles will be the same then. Yeah. Okay. Alright, so now we've got this one. Okay. So the first thing I need to do is solve for angle A1, but I no longer have to, I don't have to use the law of sines to do that because I've got this situation right here, right? So if I know this angle right here is 63.106, and that means so is this angle. And then this angle is a linear pair with that. So all I got to do to find this one, so angle A1 equals 180 minus angle A2, okay, which is 63.106. So 180 minus 63.106 would be 116.894. Let me check that real quick. So 180 minus 63.106. Okay, 116.894 degrees, good. If I know this one, 116.894, then I can do 180 minus those two and solve. So 180 minus this and minus 43. I guess I could have just said that minus 43. I get 20.106. So this angle right here is 20.106 degrees. And then one more law of sines in order to solve for side C1. So C1 over, it's the sine of its angle, so sine of 20.106 equals, we'll do the angle and side pair that we were given, 13 over sine of 43 degrees. Multiply by that. So sine of this times, we're going to multiply this by 13, and then we're going to divide by sine of 43. And we get 6.553. So that means this right here is 6.553. Okay. I guess I did have one more problem, so let's go on to an application problem. Okay. Oh, good question right here before I go to the application problem. It says determine if the information given can be used to create a triangle, then determine whether or not the law of sines can be used to solve it. If so, solve. Angle B equals 31 degrees. Side A equals 8, and side C equals 11. Okay, so if I try to set up a triangle, side B is 31 degrees. I know side A, we'll let this be A, is 8, and side C is 11. Okay. The question is, can this used to be create a triangle? Sure. I think, you know, if this being 11, this being 8, all we gotta do is connect those, right? But as far as solving it right now, we don't have enough information because the only way that you can use law of sines is if you have an angle and a side pair. We have an angle, or we have a side A but no angle A. We have a side C but no angle C, and we have an angle B but no side B. So we law of sines not possible. Okay. Okay. I've got a problem that says two meteorologists are 25 miles apart located on an east-west road. Okay, I'm gonna move my camera. That's at an angle. Sorry while I figure this out. Okay. 25 miles apart. Okay. So two meteorologists on an east-west road spot a tornado. Oh, okay. Two meteorologists 25 miles apart located on an east-west road. The meteorologist at point A sights a tornado at 35 degrees east of north. Okay, so we're going to assume this is A. We're going to use some of our directionality. Spots a tornado 38 degrees east of north, so we're going to say north 38 degrees east. So we're going to start with up north and then go 38 degrees east, which puts me in here. Okay. And we don't know where the tornado is, so I'm going to keep on. Okay. The meteorologist at point B, well, I'm just going to keep on going with that. Okay. The meteorologist at point B sights the tornado 53 degrees west of north. So that means north 53 degrees west. Okay, so here's north. 45 degrees is like in here, so 53 degrees would be like in here. So from north, 53 degrees west. Sorry, I'm going to tilt it real quick so I can draw. It's going to put me at this bearing, right? Which means the tornado is right there. Okay? Alright. Find the distance from each meteorologist to the tornado. Also find the distance between the tornado and the road. Okay. So I need to find this distance right here. From meteorologist B to the tornado, that's side length A. And then from meteorologist A to the tornado is side length B. And then I'm also supposed to find the height. Well, the distance from the tornado to the road, and that is going to be the height of this triangle if you look at it like that. Okay, so what do we know about this triangle? In this triangle right here, I know that I have a length of 25. I also know that this right here is a right angle, which means if this is 38, then this is 52 degrees. And then I know that if this is 53 degrees, then this is, let's see, 27. And I know that the three angles in a triangle add up to 180, so if this is 52 and this is 27, then that means that's 79. So that means 101? Yeah? 101 degrees. The way I drew it, it looks like a 90 degree, but whatever. So 52 plus 27, yeah, I'm doubting myself on that. Okay. So here's the thing. I know this angle is 101 degrees. I know this side length is 25. So using law of sines, I can solve for both of these at different times. So let's solve for side A first. Okay, I need side A. Its angle pair is 52, so we'll say sine of 52 equals, and then we'll do the angle and side pair we were given. 25 miles, and then sine of 101 degrees. Oh, okay, so now I'm trying to solve for A, so I'm going to multiply both sides by sine of 52. And we're going to type that in. So 25 sine of 52 divided by sine of 101. 25 sine of 52 divided by sine of 101. And that is going to be 20.069. 20.069. So that means A is is 20.069. And, okay, so as far as, like, answering the question, that means meteorologist. Ologist B is 20.069 miles from the tornado. Okay, so don't forget the units. And then to solve for B, we're going to set up a law of sines again, only this time we're going to use sine, or angle B. So B over sine of 27 equals, we're going to use the angle and side pair we were given, again 25 over sine of 101. Okay, so we're going to multiply by that's interesting. I wonder why that one's shorter. Oh, duh. Okay, sorry. This is the largest angle, which means that should be the longest side. I don't know what I was thinking. I don't know why I was thinking that needed to be longer. Okay, sorry, brain fart. Okay, we're going to multiply by sine of 27 on both sides, so 25 sine of 27 divided by sine of 101. And that gives me 11.562. 11.562. So B equals 11.562. Which means meteorologist B is 11.562 miles from the tornado. So meteorologist, sorry, A is 11.562 miles from the tornado. Okay, now we're done. I'm going to post the homework. It's got some work just on the paper, and then it's also got some book work, okay?